All right, folks, here we go with the notes for Chapter 3, talking about the radio console. It's going to be kind of a challenge to do this as a lecture because a lot of the things that we're kind of talking about in a theoretical sense, and it really helps to be able to be in a studio and see all of these different elements, which we're going to get a chance to do in class. Also keep in mind, though, that different radio studios are set up in different ways, so what you might see in one studio could be a completely different setup from another one. Nevertheless, we're going to try our best in the lecture to be able to talk about these things in a general sort of way. The audio console is simply a device for amplifying, routing, and mixing audio signals. Let's talk about each of these things in particular. First off, amplification. That is simply just the boosting of an audio signal to a usable level, increasing its volume, increasing its loudness in such a way that the audio can be enjoyed and experienced. That's amplification. The console allows the producer to determine the path of the signal, or in other words, to route it to a certain output, like over the air or to a recording device. You could have several things going on in the studio at the same time. Have content going out over the air, have another piece of audio being recorded for later use, monitoring a third piece of audio that you're either going to record later or put out over the air later. You have that sort of versatility in most radio studios. The console can put two or more signals out at once. The console also allows the volume of each to be controlled separately, and this is what we call mixing elements. This allows for the song, the ending of a song to be able to be played over top of the beginning of another song, to have voiceover over music and effects and things like that in a live situation. Now, let's take a look at some of the console functions that you're going to encounter. Now, for a lot of these different discussions, you may want to refer to diagrams in your textbook to be able to see some of the things that we're talking about. The signal from some input devices is very weak. So a device called a preamplifier, this is usually shortened to the term preamp, boosts it to a more useful and usable level. Microphones are a really good example of that. You're going to have a preamplifier or some phantom power that is going to provide enough boost to the microphone in order for it to be able to be used within the scope of what you're doing in the studio. From there, you have a potentiometer, fancy word for volume control. The potentiometer is almost always referred to as the fader. You might hear some radio professionals refer to it as a pot. And this kind of goes back to the days where a lot of radio consoles, instead of having an up and down fader slider, actually had a rotary dial that increased and decreased the loudness of audio. And that's where we tend to get the word pot from. The on button is essentially a switch that puts the signal out over the air when it's pushed. Some audio consoles identify this as a program button. Other consoles may have one or more channel buttons right below the slide fader or a program select switch at the top of the fader, and these are called routing switches. So in addition to the program button, we mentioned that you could have audio going to all sorts of different places. We'll get a little more into that later, but you can put audio out more than just to the output of what you're sending over the air. The volume unit meter, that's the long name for the VU meter, which hopefully you all are familiar with at this point, at least on the software that we use for recording. But there is a VU meter on the console as well. And this gives an objective visual representation of loudness. So this will usually show up either as an electronic bar, or sometimes it'll be a needle that moves that shows the relative loudness of everything that's being sent out. The most important aspect of reading a VU meter is to know that 0 on the top scale is the reference for proper volume. We want to get as close to zero as we can without going over. So think of Price is Right rules. And here's the consequences of not doing that. A reading above zero, that's known as being in the red because that part of the scale above zero is often colored red. This results in distorted audio, sometimes even clipping of audio to where you no longer hear the audio because everything's just being pushed out too much. Too low of a reading will result in too low of a music level and too much electrical noise. And this is known as an unacceptable signal to noise ratio. So with all of the electronic components that are in a studio, it's possible for that machine noise and electrical noise to be able to be heard over top of the actual audio that you want to have presented. And if we're not pushing volume levels enough in the studio, that electrical noise can wind up taking prominence. A reading consistently lower than -20 is known as running in the mud. So in addition to having that poor signal to noise ratio, you get this audio that just isn't very clear and has what we kind of consider a muddy sort of sound, that it winds up being not very clear, kind of incoherent. So you want to be mindful of that VU meter. Make sure that you're putting audio out at decent levels. Some VU meters indicate the percentage of modulation, which is the imprint of sound on a radio signal. 100% in this case is ideal. And again, there's problems if we're not watching our modulation. So for our purposes, think of modulation kind of just as a different way of talking about VU levels, where modulation we're basing on 100, whereas on a normal VU, we're talking about 0. Too much modulation results in an over-modulated, distorted signal. Too little causes problems with signal-to-noise ratio and makes the signal sound muddy or weak. The major task facing a console operator is to keep the needle on the VU meter hovering around the points marked 0 VU or 100% modulation. Keep that in mind. Watch your levels when you're in the studio. The monitor is a loudspeaker or headphone that lets the operator hear what's going over the air. This is the operator's personal speaker. It does not affect the sound going out over the air. And this is nice in that you can adjust the volume level of your headset or the monitors in the studio to be comfortable for you to be able to listen to. But that's not going to impact what is actually being put out over the air. Again, we have the VU meter to help us to determine that. Before the signal leaves the board, it is usually amplified or boosted again. The final step, therefore, involves putting the signal through that amplifier. That's an automatic process that happens within the console. As long as you're mixing things properly, you're watching those VU meter readings, the board should take care of that final amplification process before the audio gets sent out over to the transmitter. Now, some terms for you. When we talk about dead air, we're talking about gaps in programming. So this is periods of no audio on the air. For the most part, dead air is bad air. There's very few cases where we want extended periods of dead air going out over a radio signal. In some instances, it's rather effective if you're listening to talk radio. Of course, certain types of classical music includes longer periods of silence than what we would want on other formatted stations. But for the most part, we don't intentionally want to carry dead air. A segue is when the end of one song and the beginning of another are overlapped for a second or two. So the way that the crossfading of those two elements happens is what we consider a segue. Sometimes it might not necessarily be overlapping audio, but a piece of audio just coming immediately after another piece of audio has finished. But the way that we make that transition from audio A to audio B is what we consider the segue. Multiple input channels. Every audio source has its own fader, its own preamp, and its own routing switch. So you have a dedicated set of items there for the microphone, for the computer output, for the CD player, for the satellite source that you may be using. All of those different elements. Each of them is going to have its own set of these elements. The Audition channel is a different output from the program channel and provides additional flexibility for the operator. This is how you are able to send audio to a recording device or to use for some other purpose other than putting audio out over the air. So this gives you the chance to, well, audition certain types of audio. Sometimes you may have several different types of audition channels. They may come in different names or different abbreviations such as mono or pre or utility. All of those sort of things might be considered different types of audition channels depending on the maker of the console that you're using. Some consoles allow for multiple outputs to be selected at once so that you could have something going out over the air and you could be recording it through a different output at the same time. That's a really nice feature, especially if you're trying to record a live broadcast, for example. The Q channel serves as one of the same purposes as the Audition channel. It allows the operator to hear a source without putting it over the air. Now, in this case, instead of the audio going out to your headset or to the monitor speakers, usually there's a little speaker built within the console itself that allows you to be able to hear what is going out over Q. One thing to keep in mind that this usually disengages the program channel whenever you're listening to something in Q. So keep that in mind. You generally don't want to use Q over something that you currently have going out live over the air. Okay, there's a special muting system that is built into radio consoles. And this is a nice little feature. What that does is that when you go to turn on your microphone and you hit the on button, the console is going to automatically cut out the audio that is coming out from the monitors. And so what happens there is that it's a feature in that if you had the microphone on while the monitors were still playing, the microphone would pick up the audio from those monitors and it would just continually loop to where you get feedback, and that's not a good thing. So when you're using a radio console, that is a very nice feature to have. It's important to note that if you're in a studio that has a more traditional mixer like you would use for music performance, or like in a public address or auditorium sort of setting, that feature is not in those consoles. So, for example, what we have in our studios, if you ever work in production C, you need to make sure that you yourself physically turn off the speakers in the studio before you pot up the microphone. Otherwise, you're going to experience that feedback issue. Headphones formed a closed seal over the operator's ears, and this prevents any possibility of feedback. Because the headphones operate when the mic is open, they allow the operator to hear himself, herself, speaking into the microphone. This is why we say you need to be wearing headphones whenever you're working in a radio studio, especially if you plan on going on the air or using microphones. Because again, you don't have the luxury of the monitors being on when you turn on the microphone in a radio studio. Some boards are equipped with a master fader. This controls the entire output of the board. The VU meter reads the output of the entire console, and these are generally, you're not going to find these a lot on radio consoles. This is more for PA systems and music production boards, but it is something to keep in mind that you may have the ability to increase the overall loudness if you have a master fader. Because a microphone generates a much lower output than line level sources, preamps on mic level channels must raise the level of the signal higher than most preamps for line level inputs. So we talked about that a little bit earlier. Microphones in many cases will need some sort of phantom power in order to amplify the sound that's being put into the microphone to be able to be used in mixing with other audio sources. When sources are used infrequently, it's not necessary to have a separate input channel assigned to each of those inputs. Using a selector switch provides flexibility. It allows an operator to decide what source is being controlled by a particular fader. Now, you might encounter in a studio something called an A-B switch. It's the same thing, where position A will allow you to, for example, control a CD player, while position B might be a satellite feed or maybe a reel-to-reel player if you encounter that, just some other sort of audio source. And generally, when you have two different options available for you for a particular fader, it's going to be something where you're generally not going to be using those two audio sources at the same time. So it makes it more practical to be able to have those audio sources share a particular fader so that you don't have to have one fader dedicated to every single audio source that you have available to you. All right, at this point, let's take a break. We'll finish up the chapter with part B of this video. I'll see you over there.